we have to be quiet?
Today is 4.1 ratios and rates and unit rates. Okay, so we're going to do some examples together. When we do rates and ratios, it's really important to understand your labels and where they go. The first example on page 156 says, Mickey can type 120 words in 3 minutes. How many words can she type per minute? So what do you ask to find?
How many words we can type in 3 minutes? So put it in a ratio.
Number of words per minute. How many minutes?
3.
What do I want my answer to be? I only want to know how many words she could type in 1 minute. So this word is going to indicate that this is like your division between your first term, which is on top, and this, which is your second term, which is on the bottom. So we're going to go words per minute. The information that I have is that she could type 120 words in 3 minutes. How much would she type in 1 minute? So I'm going to solve for an unknown. I don't know my first term. Okay, cross multiplication is different than cross simplifying. Okay, you cross simplify when you're multiplying fractions. Cross multiplying is when you multiply the terms that are across from each other. You get 120, and then you divide it by the second term that's across from your unknown. So I'm going to go divide by 3. Your basic fact is 12 divided by 3 is 4. You put a 0 back on. How many words can she type in 1 minute? 40 words per minute. All right, let's try another one. Cubic meters of silver has a mass of 41,960 kilograms. What is the density of silver? Okay, density is mass over volume. You may have learned about this in science. Okay, so you know that your units for mass must be your first term on the top. And you know that your volume must be your unit that's on the bottom. Volume is like what dimension? Right, so volume is cubed. So if we look at what information that we are given, we know that 4 cubic meters, which is what term? Mass or volume? Volume. So I'm going to put on the bottom, 4 cubic meters of silver has a mass, which term? So when we talk about ratios, the top one is our first term, and the bottom one is our second term. Okay, so if I listen to this piece of information, a mass of 41,960 kilograms. Is that mass, term 1, or is it volume, term 2? It's mass. So I'm going to put on top 41,960 kilograms. Use your labels. Now, it says, what is the density of silver? Okay, this is written in density format, but we want a unit rate. And whenever we talk about a unit rate, our second term, our bottom, must always be 1. So I'm going to create a proportion. Now we can use cross multiplication. You know that 41,960 times 1 is 41,960. And then you're going to divide it by 4. Okay, you can do this on your calculator. You would find that it would come out to be 10,490 kilograms. Okay, therefore you can say that silver has a density of 10,490 kilograms per meter cubed. I can write it this way as well. Because what does this stand for, that bar? Per. Yeah, or each. Good. Let's try the next one. Example 2B. Aluminum weighing 1,350 kilograms has a volume of 5/10 cubic meters. What is the density? Same thing. You know density is mass over density. Or volume, sorry. Mass over volume. So you need to put mass on top, your first term, which is what information from the text. 1,350, put a label on it. We're doing kilograms? Yes. Over a volume, your second term would be 5/10 meters cubed. I want the density. Therefore, what does my second term have to be? If I'm doing a unit rate, my second term has to be 1. Same thing. So you're going to go cross multiply. 1 times 1,350 is 1,350. Divide it by 5/10. You're going to get a bigger number. You get 2,700. Put your label on, kilograms. So then you would say aluminum has a density of 2,700 kilograms per meter cubed. Whenever I say unit rate, the second term has to be 1. So then you can just convert to an equivalent ratio. Because is this ratio equivalent to this ratio? Yes, it is. I just converted it to a unit rate, and I know that unit rates have to have a second term of 1. Okay, example 3. A band's tour bus is traveling 525 miles from Charlotte, North Carolina to Orlando, Florida. In the first 5 hours of the trip, the bus traveled 260 miles. What is the bus's average speed? You know that speed is what?
How fast do you go?
It's two-dimensional. Speed is two-dimensional.
Sure.
You're talking about how far you go in a certain amount of time. So it's distance over time. So when you go back to your problem, what information are you going to use? Do I know how far the bus went? Yes. 260 miles. Do I know how long it took them? 5 hours. Now, I want their average speed. Again, speed is calculated into a unit rate. Therefore, my second term must be 1. So I'm going to go 1 times 260 divided by 5. Do you guys know what it is? Get a calculator out. 52 miles. So then to answer the question, you would say the bus was traveling at an average speed of 52 miles an hour. It is kind of slow. But you have to remember, you're on a bus. It's bigger. It's heavier. Okay, the next one, example 3b, says the driver estimates that the entire trip will take 8 hours. If the bus keeps traveling at the same average speed, is the driver's estimate reasonable? Okay, so we know that how far a bus can go is going to be determined on how fast they drive, the rate of speed, R, times how long they drive. Right? Look up here.
Yeah. Sure.
We know that speed is this speed, which I'm going to use speed as R, because R stands for rate. Is that the same as like the rate of how fast you're going is the same thing as saying speed?
RT is rate.
This is standing for speed. So this that we were talking about up here, how far you go, divided by how long it takes you, is going to give you your speed, your rate. If I just rearrange this formula for D, so I'm going to go multiply by T, multiply by T. This cancels out. I'm left with D equals R times T. Does that match?
Yeah.
It does. I'm just rewriting my formula so that I'm solving for D. Because if I go back to example B, it says that the driver is going to thinks that the trip is going to take 8 hours. There's my time. How fast are we driving? 52 miles per hour. Do we know how far the whole trip is?
We can, but no.
We do. If you're looking in the textbook at the top, I say that the band's tour bus is going 525 miles from Charlotte, North Carolina to Orlando, Florida. So the whole trip is 525 miles. Now, I'm going to show you how this works with your units. If you line your units up correctly and use the idea of cross multiplication, you can set your problem up correctly to solve for what you want. I know that 8 as a whole number can be written as 8 over 1 without changing the value, right? I know that if things are across from each other, first term to second term, that they can cancel out, right? I have hours on top and hours on bottom. Guess what they're going to do? They're going to cancel each other out. Am I left with the units that I want, my distance? Please stop. I'm left with distance, which is in miles. So then if I check this, what is 52 times 8? Because I want to know, is this reasonable? If he goes 52 miles per hour for 8 hours, will he get 525 miles down the road?
No.
How far does he get?
416.
What'd you say?
416.
416. Okay. So then to answer the question, you would say, no, he would not make it to Orlando, Florida. That is 525 miles away. He would only make it 416 miles if he went 52 miles per hour.
They'll have to take about 10 hours.
Yes. And that was the next question I was going to ask. Can you figure out how long it would take?
It'd have to be 11 because they only get 520.
Right. Can you figure out how long it would take? Sure. Just say 525 miles is what they have to go.
What is going on?
Just ignore it for right now for just a minute. You're going at a speed of 52 miles per hour times how long would it take to get there? So you would just go 525 divided by 52. What do you get?
It would be 10.
Is it like 10.1? Yeah. So you would say it'd take about 10.1 hours to get there. All right, example 4, finding unit prices to compare costs. When you guys are in the store and you're trying to figure out, like if you're, I know you guys probably don't do this, your parents probably do, but if you're buying like cereal, you can figure out what cereal is the least expensive by comparing unit rates. That's when your second term is 1.
Well, I just look at the prices.
But listen, are all boxes the same weight?
No.
No. So something that weighs more but costs a little more might sometimes be cheaper than something that weighs a little bit less. Okay, so for example, it says Arnie can buy a 16-ounce box of cereal for $5.49. So we have 16 ounces for $5.49. Or he could buy a 20-ounce box for $5.99. Which one is the better buy? So we need to do unit rates. So we're going to do cost per ounce. So we're going to go cost per ounce. Cost per ounce. And we're going to figure out how much it costs for 1 ounce so we can compare it to how much it costs for 1 ounce on the second one. So you're going to just use cross multiplication, which ends up being 549 divided by 16, which is
0.37.
it should be 34 cents. Okay.
49 or 99?
$5.49. $5.49. And then we can figure out what would the cost be for 1 ounce of the second kind of cereal. So you're gonna go $5.99 divided by 20.
It's 30 cents.
Yeah, is it like 0.2999? Okay, you round it to the nearest cent, which bumps it up to 30. Which one is cheaper?
The 20 ounce.
This one's cheaper. Therefore, you would say the better buy is the 20-ounce box for $5.99. That's why you can't always go with the cheaper, because if you would have bought the $5.49 thinking, oh, it's less money, is it really the better buy? No, you're paying a little bit more per ounce of material in that box.